Welcome back, students. We're going to continue what we were talking about with solving systems of linear equations, and this time we're going to work on a word problem. So, in this problem, we have an amphitheater that charges $75 for each seat in section A, 55 for each seat in section B, and 30 for each lawn seat. There are 3 times as many seats in section B as there are in section A. The revenue from selling all 23,000 seats is $870,000. How many seats are in each section of this amphitheater? Okay, so first thing, when I approach a problem like this, I pay close attention to what the question is asking for. How many seats? So the number of seats, these are my variables that I'm going to be using. That's what I'm trying to find out. That's the big unknown. Now, I do see that we have a different number of seats for the sections. So let's go ahead and say that for section A, we're going to call all of section A, the number of seats in section A, as our X, the number of seats in section B as Y, and the lawn seats will be Z. Okay, now that we've decided on that, let's go ahead and set up some equations related to things that they've told us. One of the easiest ones is I'm noticing there are 3 times as many seats in section B as in section A. So let's first write that just in words. So seats in B is equal to 3 times as many seats in A. All right, so there's one verbal equation that we have. Another thing they let us know, we know how many total seats there are. Okay, well, so this should be pretty straightforward. If we take the seats in A plus our seats in B plus the seats on the lawn, that should equal the total seats. Okay, great. Finally, they let us know how much money would be made if all the seats sold out. So we know how much revenue total, but what about the revenue from section A? Well, I know that it's $75 for each seat in section A. So if only one person bought a seat, 75. If 2 people bought a seat, 150. Essentially, I'm just going to multiply the number of seats in A by a 75. And we would call that the revenue that we get from A. So to get our total revenue, we have revenue from A plus revenue from B plus the revenue from C should be the total revenue. All right. Now that we've got those kind of written out in words, let's now write them as equations. So we decided seats in B was going to be a y, so this is going to be y equals 3 times the seats in A, or in other words, 3x. Okay, our next equation, seats in A plus seats in B plus seats on the lawn is equal to the total number of seats, which was 2,300. Now the revenue at A was taking the cost, 75, times by the number of seats. Revenue from B was going to be the cost per seat times by the total number of seats. And the revenue for the lawn, cost per seat times by the number of seats. And all of that together should give us 870,000. Fantastic. We got equations that we can now start working with. Now, different from the way we did it last time using elimination each time, I'm actually going to use substitution. Right here, I have a nice little equation that tells me y is the same as 3x. So I'm going to take my other two equations and I'm just going to replace them with 3x. Okay, so let's go ahead and do that. So I'm going to have x plus y is a 3x plus z. So you see just a simple substitution there. And that'll be 4x plus z equals 2300. All right, for the next one, 75x plus 55, y is just a 3x, plus 30z equals 870,000. And that is going to give me 240x plus 30z equals 870,000. All right, wonderful. I've now got two linear equations in two variables. I can use these to solve for one of them. So I'm going to go ahead and now I'll use the elimination method. I eliminated y's from my equation using substitution, but now let's go ahead and use our trusty elimination method. Let's write that second equation. So 240x plus 30z is equal to 870,000. Now, I want to eliminate one of the variables. Z has a coefficient of 1, so that's going to be easy. I'm going to multiply all of this second equation by a negative 30. So I'll get negative 120x minus 30z, and that should be equal to negative 690,000. Ooh, that was weird. Okay, now that we've got that, just subtract down. So 120x is equal to 180,000. Divide both sides by 120. And x is equal to 1,500. Well, now that I know how many seats are in A, 1,500, I know that there are 3 times as many seats in B. And now that I know how many seats are in A and B, we could even use this equation to solve for how many are left. Or in other words, 23,000 minus 4,500 minus 1,500. And that'll give us 17,000 seats. Okay, so we've identified the number of seats in A, seats in B, and seats on the lawn. I hope this helped you. Good luck on your practice.